Welcome to Ask and Learn.
We are going to sketch the graph of the function 1 minus square root of x, and we'll use that graph to find the absolute and local maximum and minimum values of the function. So there is no domain specified here, so we are going to use the domain implicit in the formula. That is, in this case, we have a square root of x, and that needs or is only defined for x greater than or equal to 0. So we are considering f of x equal 1 minus square root of x for x on the interval 0, including 0 and plus infinity. That is for the non-negative number x. Then we know that the square root of x is inverse of the of x squared for the positive numbers. That is, we're going to do some transformation to arrive to the graph of square root of x. So we have this, let's say the parabola x squared, something like this. It has a negative part, but we don't, that is a part which corresponds to the images of the negative numbers, which is just to reflect a reflection of this with respect to the y-axis. But we know that we have to consider only x positive, so this is the part of the parabola x squared we got to consider. So here we have, let's say, y equal x squared for x greater than or equal to 0. And we know that to find that the inverse of that, we get to draw the identity function, that is the line y equals what? Y equals x, let's say that. And with that, we made a reflection with respect to that line, and we get the inverse of the function. So we are going to get something just a little bit like this. Let's say something like not so bad like this, but trying to make a little bit idea of the reflection. Okay, and it's endless to the right, as was the parabola. So now we take out the parabola here, for a moment, because we already found the inverse of the parabola, and we have this. That's square root of x now. And how we did it? We draw the parabola x squared for the positive x only, because if we take all the parabola, it's not an injective function, so we need to take only the positive part, that is for the images for the positive x of the parabola. We draw the identity line and we made a reflection through the line. We know that the inverse of the functions are constructed that way. So now we have the square root, and now we got to change sign of that. That is negative square root of x, and that means a reflection with respect to the x-axis. So we get this, more or less. So this is negative square root of x now. And we can get rid of this for the moment. And we have this. And we get the sum 1 to add 1 to get f finally. So to get f, we add 1, and we know that we have to displace the function completely as is 1 unit upward. That is because all the images of this function here get to be at 1, and that make a displacement of 1 upward. So we can say we have now this function, more or less. So we can say that we can get rid of the previous graph. We have already our function here. Now we have some values we recognize here because we place 1 at 0, we get 1, f is equal to 1, so the point is included in the graph because for x equals 0, the function is well defined. And this value here, corresponding to the intersection with the x-axis, is now x equal 1. Okay, so let's say here x equal 1, because when we put x equal 1 in our formula here, we get 0. And after that, the function is decreasing all the time without any bound. And that's the idea. So we have a function which is always decreasing. At 0, we have value 1. At 1, we have value 0. And the function decreases without any bound. So it is clear that there is no absolute minimum because the function doesn't stop to decrease. So we have no lowest point in the graph. Of course, no local maximum nor minimum, because at any point of the graph we have always values greater and smaller than the value at the point. And we have as the highest point in the graph, which is 0, at 0, which is the value 1. So we have an absolute maximum of 1 at 0, and it's not a local maximum because we have no graph to the left. So we can write all these observations here. F has an absolute maximum value 1, which occurs at x equals 0. And let's say here f has no local maximum at all, because at any point we have a smaller and greater values than the image of that point if we take any any small interval containing the point. So we have this and this, and now for the minimum, we don't have either a local nor absolute minimum. F has no absolute or minimum or local, minimum. And that's it. That's the behavior of the function 1 minus square root of x, which we found by doing some transformation to the basic functions. First, we took this parabola x squared for the positive values of x. We did a reflection of that with respect to the identity line y equals x. We did that because that's the way of graphically finding the inverse of a function. After that, we changed the sign of the function, which was a reflection with respect to the x-axis, and then we displaced upward 1 unit. And with all those transformations, we got the function f, which is this red line here. And because of the behavior of always decreasing of the function, we know that there is no local nor maximum, or local or absolute minimum. There is also no local maximum, but there is an absolute maximum value at 1, this point here, the value 1, and that occurs at the value of x equal to 0. So this is the analysis for this function.